Hello and welcome to my Pre-Algebra review series. This video covers Chapter 1, Section 3, titled Evaluating Expressions. By the end of this video, you will have reviewed the procedures for evaluating variable expressions, plus you will have used those procedures in your review of solving problems by evaluating expressions. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's look at solving some variable expressions. Okay, before we get started, let's go over definitions. Evaluate. To evaluate a variable expression, you must first replace each variable with a number. Then use the order of operations to simplify that expression. Okay, our first objective, evaluating variable expressions. To evaluate a variable expression, you must first replace each variable with a number designated as its replacement. Look closely at all members of the expression to locate each variable and replace each with the appropriate replacement number. Then, after replacing each variable, you will use the order of operations while simplifying. Okay, example 1, evaluating a variable expression. So our expression that we're going to evaluate here is the 4y minus 15. And what we're going to evaluate it for is y to be equal to 9. Okay, so I'm going to go ahead and just write it 4y minus 15. Okay, and then we're going to evaluate the y. So we find there's only one y in here. So we're going to say 4 times 9 minus 15. If we carry out according to PEMDAS, the order of operations, we have to do the multiplication before addition and subtraction. So we're going to end up with 4 times 9 is 36, and then we're going to say minus 15. And when we do that, we're going to find out that 36 minus 15 is 21. Okay? Okay, example 1, check your understanding. Directions, evaluate each expression. So let's go to it. Problem A is 63 minus 5x. And they want you to now substitute this x, a 7 for the x. We found the x, it's right here, and we're going to replace it with a 7. So to do that, we're going to say 63 minus 5 times 7. Okay, so now we found all the x's, there's only one, and we've replaced it with a 7. So now we're going to do, according to order of operations, we're going to do the multiplication and division first before the addition and subtraction. So what we're going to do is we're going to say 63 minus 5 times 7 is 35. And then that equals, now we can do the final subtraction here. It's all that's remaining. 63 minus 35 is 28. Okay. B, the problem 4. We have a distributive properties issue to look at here. 4 times the quantity t plus 3 plus 1. And we're going to evaluate t at the value of 8. So we have to find all of our t values, and there's 1 right here inside these parens. So we're going to say 4 times t, we're going to replace it with an 8. So we're going to say 8 plus 3 plus 1. So now we have parentheses. Parentheses is the highest order in the order of operations. You have to do everything inside the parentheses first. So what do we find? We find an 8 plus 3. So it's 4 times, that's this parentheses is giving us a times right here. 8 plus 3 is 11 plus 1. Okay? Now, this is pretty much cleared. The parentheses are cleared. There's nothing that we can reduce inside here, so they can literally be removed. But in doing so, we're leaving them in the problem so that we can pull off this multiplication, because multiplication goes before addition. Here's addition. This is multiplication here. We have to do the multiplication first. And when we do that, 4 times 11 is 44. And then we can say plus 1. And that equals what? 45. 45. Okay, now in example 2, we're going to replace something that's a little more complex. It says replace more than one variable. Not any harder technically, you just have to do more steps. So I'm going to rewrite the equation. So we have a 3, and it's times a times b. That's what that means. 3 times a times b. The variable is not ab. It could be, but it's not. So the variable is a times b. 3 times a times b plus the variable c divided by 2. So we're going to go through our equation here, if we will, and we're going to replace every a value with a 2, every b value with a 5, and every c value with a 10. So when we do that, we're going to have 3 times the a value, which is a 2, and I'm using parentheses to indicate the multiplication going on here. And the b we're going to replace with a 5, so we're going to put a 5 in here instead of the b. So now we have 3 times a times b, or 3 times 2 times 5. And then we have a plus sign right here, a little plus sign, plus c, right here, c, which is 10, plus 10 divided by a 2. Okay, so now we have this, all of the values replaced. Every a, b, and c is replaced with a 2, 5, or 10 respectively. So now we can do the math. And PEMDAS, or our orders of operations, say that you do the multiplication and division before you do the addition. Here's the addition. We're going to do that last. So we're going to do 3 times 2 is 6, and times 5 is 30. 3 times 2 is 6, times 5 is 30. And then we're going to, the plus is next in line. 10 divided by 2 is 5. Now we can do the final addition here. 30 plus 5 is equal to 35. Okay? Good deal. Okay, example 2, check your understanding. So look at this. We have 3 problems we're going to do and see if we can get these done here. So what is the first expression? The first expression is 6 times the quantity G plus H. And they want to replace G with an 8 and H with a 7. So now we're going to rewrite this. We're going to say 6 times G, which is 8, 8, and H, which is 7, and these are added. It's G plus H, so we're going to say plus 7. Okay, so now this has been, the variables have been replaced. So now we go through and we can add, you would normally say, I'm going to do multiplication first, but you can't. You have to do the parentheses first, everything that's inside the parentheses. And even though this is addition, that's what's inside the parentheses. So you have to do it first. So doing that first, we get a 6 times 8 plus 7 is 15. Okay? And then we're going to, when you multiply this out, 6 times 15 is what? 6 times 15. You can't reduce the parenthesis anymore. You have to do the multiplication, and you end up with 90. Okay? B, 2xy minus z. And you were going to replace the x with a 4, the y with a 3, and the z with a 1. So we have a 2 times x equals 4 times 4 times, here we have a y equals 3, 3, and now we have a negative sign, negative, And then now we have a z, and the z we're going to replace with a 1. So we're going to put a 1 here. So when we have to do all the multiplication before we can do the subtraction. And the multiplication says 2 times 4 is 8, times 3 is 24, minus 1 is equal to 23. Now down for C. Down here, let's not forget C. R plus S divided by 2. So what is this says? First of all, R plus S divided by 2. And we're going to replace R with 13 and S with 11. Excuse me, I had to pause for a second. So now we're going to take and replace the R and the S value with the appropriate values. And they are, the R value is going to get replaced with a 13. So we're going to say 13 plus S, which is 11, divided by 2. Well, we learned from the order of operation rules that a fraction bar, this fraction bar right here, it's the same as a grouping symbol. And what it's telling you is that everything above the bar is grouped together, and everything below the bar is grouped together. Well, there's only one item below, but you can think of it as grouped together. Okay, and above the bar we have, I'm going to say equals 13, and you have to do the groupings first. So you have to do all the groupings above and the groupings below before you can move on to actually doing the dividing, because these groupings have to be done, and that's why I drew the parentheses, because those are grouping symbols. So that has to be done first. So 13 plus 11 is what? 24. 24. And that's completed, and the 2 is on the bottom. And 24 divided by 2 is 12. So moving on to objective 2, it says solving problems by evaluating expressions. And you can write and evaluate variable expressions to solve problems. Let's see some. Okay, example 3. It's a real-world problem. It's a purchasing problem here. Energy drinks come in cases of 24 bottles. It says, write a variable expression for the number of cases a store should order to get B bottles of energy drinks. Well, first of all, you should know that when we write the variable here, we're using a B for the number of bottles. And the reason the B is because we used a B right here in bottles, and it helps us remember. If we use a B for the variable, we'll remember in the future that, B was for bottles, or the number of bottles. It's kind of a little trick that you can use to help keep it straight in your mind. But if you know that there's 24 bottles in a case, and you want, 100 bottles or whatever the case might be, you're going to say 100 divided by 24 will give you the cases. Okay? So the variable expression here is the number of bottles that you want, B bottles, divided by 24. That's in terms of cases. So if you had 240 here, 240 bottles you wanted, you would divide 240 by 24 and you would get 10 cases. 240 divided by 24. So this is your variable expression, B divided by 24. So in problem B it says, evaluate the expression for 120 bottles. Okay, so there we go. So what we're doing is we're going to take our expression, B divided by 24, it's the expression we created over here on the A side, and we're going to rewrite it as 120 over 20, just like I said. 120, 240. So what is this going to equal? In this other equation, on the other side, I said if I had 240 bottles and divided by 24, I'd have 10 cases. Well, on this side, we're going to find that 120 divided by 24 is 5. So we use that formula, this variable expression, to solve this problem we have, which is, how many cases do I have to order? And just for your information, if this was 110 bottles, you'd have ended up with a fraction. 24 would not have gone into 110 evenly. So you would have had to order one more case. That's a little tricky. You have to order one more. You have to round up so that you can get the few bottles that you missed by the 24. Anyways, just remember that as you're moving forward doing your math. Okay, example 3, check your understanding. It says evaluate. Just like before, the store in example 3 pays $29 for each case of energy drinks. Write the variable expression for the cost of C cases and evaluate the expression to find the cost of 5 cases. So what is the variable expression you'd write to find out what is the cost of so many cases? We'll say C cases. Oh, in fact, it even says that. C number of cases right here. So what is that variable expression? Well, we know it's $29 per case. And if you want C cases, you're going to say 29 C times, or times C. So your variable expression is 29 C. C is the number of cases. If you replace that with 5, you're going to get 5 times 29, and that's going to be your, if you had a dollar sign out here, it would make dollars. It might make more sense since it's a story problem. But then over here it says, write a variable expression for the cost of C cases and evaluate the expression for 5 cases. So what is the answer for that? We have $29 times C, and I'm going to replace the C with 5 cases, and that equals 20 times 5 is 100. 9 times 5 is 45. So it's $145. Example 4, evaluating a variable expression. Online shopping. An online music store charges $14 for each CD. $14 right here, $14 for each CD. Shipping costs are $6. So that's usually something that adds on to what you're purchasing, right? It's an add-on. Write a variable expression for the cost of ordering CDs. And then find the cost of ordering 4. When we're done, they want us to find the cost of ordering 4 CDs. So let's first of all find the variable expression. So if we let N, we need the number of CDs that they're purchasing, right? Find the cost, write a variable for the cost of ordering a certain number. So we want N to be the number of CDs purchased. And number, remember I talked about using the N here, equals the N there, so now I know the number of CDs. And the expression, the variable expression for ordering CDs is 14. It's $14 each, $14 right here each, right here, 14 each, times the N number of CDs purchased, right here, plus, as you see, the plus $6 per order. So that's an additional, like shipping cost, right? Shipping cost. You add that on. It's a plus value. So now you have the variable expression, and we're going to replace it now to solve for ordering 4 CDs. So if we do that, we're going to have 14 times how many CDs? 4. Plus 6, the shipping costs, which is fixed, and that equals something. Well, what does it equal? Well, first of all, we have to do 14 times 4. 14 times 4 is 4 times 10 is 40. 4 times 4 is 16. 56 plus 6. Okay? And we had to do this multiplication first. According to PEMDAS, according to our rules of an order of operation, you have to do multiplication before you can do this addition. Okay? 56 plus 6 happens to be what? 62. So $62 is our answer on this. So, okay, here's our example 4. Check your understanding. Directions. Evaluate the expression in example 4, which is the one above the example to find the cost of ordering 7 CDs instead of what we did 4 in the last one. So what was the variable expression from the last slide? It was right here, 14n plus 6. So here's our n value, right here, n, and we're going to replace the number of CDs with 7. So we have 14 times 7 plus 6. We have to do the multiplication first. So 14 times 7, 10 times 7 is 70, 4 times 7 is 28. So we're at 98, 98 plus 6, and 98 plus 6 is, and I'm going to say dollars because this was dollars up here, dollars, that's the cost. 98 plus 6 is $104. Very good. We've completed this section.